Hello, and welcome to our bonus conversation. This week, I thought I would talk through, or in this session, talk about Databricks structured streaming. In particular, it's actually Spark structured streaming, but we'll be seeing it inside of Databricks, so we can say it's Databricks structured streaming. So first of all, what is it? Databricks, unified platform that uses Spark to solve big data problems. It's available on both Azure, AWS, and now GCP, Google Cloud. So pretty much the big cloud providers, it's available. Obviously, you can run Spark yourself. Databricks is Spark plus a lot of value adds. It's all about compute, about processing. They do a certain amount of storage, but generally speaking, they layer on top of other storage systems. So things like Azure Data Lake or Azure Storage or S3, various other kind of cloud technologies for storages. It's not a storage system like something like Hadoop is, for example. So very much about processing, even though they do support storage. So why should you use it? It works very well with a data lake architecture, and in fact, Databricks is championing what they're calling a lakehouse architecture, which is a combination of a data lake and a data warehouse in a unified, controlled fashion with data lineage, data sharing, data governance, and so on built in an open ecosystem sort of way. The basic idea is that you land things raw, you refine them to as needed before consumption, and so on. Why is it popular? Well, it's more flexible than things like mapreduce and Hadoop. It's also, generally speaking, more cost effective, especially in the cloud, because you're paying for the processing you use, not for the cluster to exist. It also supports a wide range of workloads, be it data engineering, data wrangling, data science, or artificial intelligence and machine learning. And it's a unified platform that does both streaming and batch. And today we'll be talking about streaming, in particular structured streaming. When you talk about streaming, you're talking about things that are processed in a continuous fashion. It's not like a batch where you start it, it does its thing, it stops, and you finish. The reason you care about streaming is because it allows for low latency knowledge and insights in action. So you can take an event stream of things like your sales traffic from your point of sale systems in a retail environment, or the location of your vehicles in a fleet management system, and make decisions based upon the information in near real time. It's not a true real-time sort of system. The thing about structured streaming is that it does use a micro batch architecture, which basically means it does small chunks of data in a continuous fashion, so that it simulates what a streaming system looks like, a true streaming system, such as something like Storm, but it does so using a pattern that's very familiar in a batch sort of architecture, sort of concept, but a very small batch. You can get sources and destinations inside of Azure, pretty much most anything. So the common ones are going to be things like event hubs or Kafka from a system-to-system type integration. You can do IoT Hub. That's generally speaking when you're dealing with devices. IoT Hub includes things like authentication and so on, so that you can manage those devices as well as receiving telemetry and information from them. And you can also control those devices through IoT Hub. Azure Storage may want to process data that is received in batch, but view it as though it's being done in a streaming sort of fashion. You can also deal with pretty much any relational source and many non-relational sources, NoSQL sources such as Cosmos DB, MongoDB, Cassandra, and so on. Structured streaming, it's basically the main way to handle the data sets in Spark. There was previously a different type of streaming, so you may see things whenever you're doing research called Spark streaming. Structured streaming is the current way of doing streaming inside of Spark. Basically, you view it as essentially an ever-growing table, and so it also uses a similar pattern to that of a batch, but it does so in an incremental execution way. There's three modes of output: complete, append, or update. Complete is going to write all the rows out append is only going to write out the new ones. Update only those that are new since that have changed since your previous output. The steps to create a simple solution, I basically took an approach and kind of repurposed it. So go out and provision an IoT hub, create a blob storage for where things are going to go to, create the Databricks workspace, set up an input and output, define the logic, and then have data come to the IoT hub from a Raspberry Pi simulator. So a web simulator that looks a lot like a Raspberry Pi, because Raspberry Pis are kind of a tinkering sort of IoT thing. And then run the notebook, and basically things get sent into the IoT hub and make it all the way to the blob storage. So IoT hub, process to create it's very similar to most other resources. You search for it, you type in IoT hub, click on the thing that says create, give it the typical sort of information we create inside of Azure, such as what resource belongs to, give it a name, pick a region for it to run in. Generally speaking, with all Azure resources, you want them in the same region. So don't put your blob storage account in one location and your IoT hub someplace else, because you're going to be paying potentially twice for the data transfers. You get charged for ingress and egress of the different regions, so keep them all in the same one. Pick a pricing scale. If you're doing this for real, you spend a lot of time thinking this stuff through. Whenever you're doing a demo, you go with the cheapest solution you can with the smallest cost incurred. So in this case, the bar is all the way to the left. You, generally speaking, for a demo, 400,000 messages in a day is plenty. Once you've done a review of everything and make sure that it looks right, you click on OK to create, and then it goes through the process of provisioning. Whenever it provisions it, your first thing to do is go in and create an IoT device inside of this IoT hub. So you click on, and it actually lands you in a pretty good place. Click on Add New Device and give it a name or an ID, which is similar to its name, and then talk about how you're going to do authentication with that device. Symmetric key is a way that basically you can share a secret key and be able to authenticate it. It knows, IoT Hub knows who the device is. You want to make a record of that information, because you're going to need it later on, especially especially that connection string, because you'll need to be able to connect to this IoT Hub with the Raspberry Pi simulator. The next step is to go through and provision a Databricks workspace if one doesn't already exist. Basic idea, similar, search for Databricks, click on create, and assign it to a resource group, give it a name and a region and a pricing tier. You get two choices there. One is standard and the other is the premium. The premium one allows things like integrated pass-through authentication. So Databricks can talk to Data Lake as the user that's logged into the Databricks notebook. So pretty useful whenever you're doing things like controlling access. Once you've created the version, go to the resource, and it's a similar pattern to a lot of other things inside of Azure these days. You don't actually see the thing whenever you go to the resource. Instead, you see a way to get to the thing. That's whenever you click Launch Workspace. Pops open another tab that has the Databricks workspace in it. Talked about the Databricks workspace before. It's basically a landing page that gives the common sort of things that you normally do up front. So the first thing you want to probably do is create a library. The reason we need that library is to talk to the Event Hub. So you search for the Maven coordinates associated with Azure Event Hubs -Spark, and that gives us the ability to talk to Spark, for Spark to talk to Event Hub. The next step is to go and create a cluster. The cluster is where you do your actual processing. Doesn't have to be a very robust one. Generally speaking, we go with standard clusters. There's also a high concurrency cluster. The idea there is that a standard cluster is essentially one person's cluster. It's intended for kind of one job at a time. High concurrency clusters are intended to handle multiple jobs concurrently. They have more intelligent scheduling configured and so on. Generally speaking, you want to reduce that termination minutes from the default of 2 hours down to 20 minutes. You're trading off cost savings versus the inconvenience of your cluster shutting down because you went and ate lunch or something. If possible, you typically want to enable pass-through credentials that allows you to be able to write from the notebook, as I mentioned, to the data lake or storage account, depending upon which one you're using. The next thing is to make sure that you have the Event Hub library that we created previously and that it is attached to the cluster. That whenever we create a library prior to creating a cluster, and especially if you say install this on every cluster that's created, that library will always be there. But this is just to make sure that it really did get installed on the cluster that we're going to be using. The next thing is to create a streaming notebook. Basically, the idea is to go and create new notebook, give it a name, pick your language. In this case, I'm using Scala. And as I mentioned before, Databricks supports lots of different languages: Python, R, Scala, and SQL. So a lot of times you want to use this particular approach. Scala lets you do a few things that you might not be able to do. You'll notice on the screen there it says the IoT connection string from Azure portal gets pasted in there. So we go over, we copy that over in case we didn't save it, update our notebook with it. And that connection string is how it's going to connect, it being Spark, how it's going to connect to the Event Hub that we created so that it can read using that read stream method that we have on the screen there. Your next step is to go and configure an IoT simulator. Microsoft provides one for free. If you search for IoT simulator, IoT Hub, Raspberry Pi, then you'll see it pop up. Basically, it also needs that connection string because it needs to be able to connect to the IoT Hub to send messages. The next step is to start the simulator. And what that does is start sending messages into the IoT Hub. Next, you'd want to start the notebook. And what that's going to do is go out and actually connect to that IoT Hub and start pulling messages in using this stream read method that we did earlier. Also notice that there's a schema that we're defining that basically is retrieving from that IoT Hub temperature and humidity and converting them or saying that those two items are both doubles. So you can see that in this particular example, the previous one, when we go and say run all and it goes out and connects to the IoT Hub, the body's not all that terribly useful because it's kind of in an encoded sort of fashion. Also, the properties not very useful as well. When we run the body through this that from JSON command and casting it as a string, it turns it into this JSON representation that we can then from that JSON essentially select the values that we care about. So the JSON telemetry, we're able to then extract out the stuff we care about from the telemetry. So that's where you're getting enqueue, time, device ID, and then telemetry underscore JSON dot star is basically giving us the humidity and temperature because those were the additional elements encoded inside of that JSON. So just like you can with pretty much anything else inside of a Databricks Spark sort of data frame, you can apply a where filter to it. So in this case, we're saying display where the temperature is greater than 27 degrees, and it will put it out into the screen. That's kind of an interesting kind of characteristic of a streaming notebook is that you can, you're connected to a streaming data frame, and when you run that command, you'll see things come into the notebook. Also, here is a temp view that we're creating, and I'm giving it the name Event Hub Data off of that Event Hub's decoded data frame that I created back here. So I create the data frame, and then I use this to create something that I can then use SQL to query. So using spark.sql or using a SQL magic command inside of a Spark cell, essentially, or Databricks cell, to run this query to say select the in-queue time as a date, and pull out various parts of it, including what hour it was and so on, and essentially get that data frame that I can then do something with if I'm so inclined, like writing it over to a storage account. So in this case, we're looking at it inside of a grid, inside of a notebook. Pretty interesting, but not nearly as interesting, and probably not nearly as likely to be used as writing it out somewhere else. So in this case, we can go out and create a storage account. Storage accounts are a commodity sort of storage environment. They support various sort of interfaces, including the blobs, the files, tables, and queues, and so on. But we go out and create one. Then we'll go and create a container so that we can actually write a blob into that container, and make a note of the keys that are necessary to access it. Then we'll come over back into the notebook. Have to do some Spark configuration here. So that spark.conf.set is a way of setting configuration values inside of Spark. And in particular, we have to tell it the key that we're using for that storage container. And then also we have to give it the folder that it's going to write to as well. And then what we do is then take the data frame that we constructed and were able to look at before, and then do a write stream, and then we do for batch. What that does is for each element of the batch, essentially persist that batch to a CSV inside of the table, or in the blob storage that we just created. So a way of basically, while it is a streaming process, the batch logic there, that for each batch, looks very similar to what you would do if you were just writing some stuff out. And probably don't really be needing to do the persist.unpersist. It's essentially a way of doing some caching, but it might make it a little faster. But that's it in a nutshell. That's basically now writing out a CSV that is in that output folder with a path name that corresponds to the path where we want to write this stuff out. So in a nutshell, that's pretty much it. The streaming jobs do run continuously. That's the key thing to take away. It's a lower level and requires some coding techniques, especially compared to things like Stream Analytics. Azure Stream Analytics is a continuous processing sort of architecture. It actually is a true streaming system where processing is triggered by the arrival of an item, versus inside of Spark, processing is triggered based upon some interval, most likely. And it also is near real time. It's not a true streaming system as like a Storm might be, Apache Storm. But it is something where you write essentially SQL type queries to do your processing. You can do cross-stream calculations with Spark structured streaming, so you can combine together two different streaming data sources to produce an output, combining those two together. And you can also write to multiple outputs. Some useful links if you want to learn more about Spark structured streaming and Databricks implementation of it. And with that, I will conclude and wrap this up. Hopefully this gives you a little bit of insight into streaming and an example of actually having seen it. One of the reasons that I decided to kind of recover this is I've been kind of doing this for real. So I thought I would bring it to the surface. In particular, been working through an exercise for becoming a Databricks partner champion, so that the idea is that I help them sell their stuff, is what the basic idea is. So anyway, this hopefully added some value. If you need some guidance or assistance with anything, do let me know. That's what I'm here for. Stay safe and have a good weekend and a good holiday. And I probably will be holding class on Monday, so if there's anything you'd like me to talk about, just shoot me a message, let me know. Stay safe. Talk to you later.